Deinterpolation is the last feature inside action linear motion. Deinterpolation is used to simplify NC programs by deleting unnecessary interpolated NC lines. Some CAD/CAM programs generate tool paths that have been interpolated into very small steps. Most of these interpolated steps are redundant. For instance, here, you can see many Z movements that can be minimized to just a single Z line. This unnecessary small steps cause long NC files, and also slow down the CNC calculation speed. You can eliminate these unnecessary lines by activating deinterpolation. To activate, just select this parameter as true. There are two different deinterpolation types in Monospos Developer. First one is linear axis, and second one is rotary axis deinterpolation. Let's first generate an NC program without activating deinterpolation. In order to show how deinterpolation affects NC output, I will generate a new NC program after activating linear axis deinterpolation. I will deactivate deinterpolation for rotary axis in this first example. When we compare the two results, we can easily see that the unnecessary Z movement steps are deleted and reduced to a single Z line as we've expected. Now, let's also activate rotary axis deinterpolation and generate a new NC program. When we compare the new one with the previous, we cannot see any difference. It seems that rotary deinterpolation didn't work. However, this NC program was specifically prepared for this demonstration, and I am quite sure that it has unnecessary interpolated lines. Then why we didn't see any change after rotary deinterpolation was activated? Let's analyze that. In order to analyze, I will use NC Analyze View. I will go to the simultaneous operation where I expect deinterpolation should be active. Let's right-click on an NC line in this simultaneous operation. I will select Go to Action. But before selecting Go to Action, I want to remind you that we made the previous changes in the top-level operation tree. What we have done inside the top level should affect everywhere, unless there is an action linear motion defined in sub-operations. Let's see that. When I select Go to Action, I can see that simultaneous operation has its own action linear motion. Therefore, what we have done inside action linear motion in the top-level operation tree didn't affect simultaneous operations. You can see that here in simultaneous operation, deinterpolation in general and rotary axis deinterpolation are not active. This is the reason why we didn't see any difference in the previous example. I will activate them both here as well and regenerate an NC program. Now when we compare the new result with the previous, we can see that there are many redundant rotary axis lines, which are deleted in the lastly generated example. You can define maximum allowable tolerances, both for angular and linear deviations by using these two parameters. You can try different values and see their effects on your own. You can also use interpolation and deinterpolation together in the same operation if you want. For instance, while deleting unnecessary Z lines with deinterpolation, you can interpolate rotary axis movements at the same time in the same simultaneous operation.